Hello and welcome to what I hope will be the first in several interviews about cryptocurrency. And for those of you who already know me, of course, these are intended for a technical audience. So we're not really going to be talking about cryptocurrency at a high level. We're going to be talking about the nitty gritty. And hopefully this will sort of resolve some of the confusions that people like myself have, or maybe some of you out there have, about what exactly crypto actually does at a technological level, or at least what people claim it does versus what it actually does, and issues like that. So my name's Casey Muratori, and my guest today is...
I'm Jameson Lopp. Nice to be here.
Thanks for joining me today, Jameson. Can you give the audience a little bit of a quick background on your experience with cryptocurrency, why you're, just kind of how you got into it, and why you agreed to come talk to me today about it?
Yeah, I'll never remember exactly what the point was that really got me looking into Bitcoin. I think it was a Slashdot article around 10 years ago. I'm pretty sure I had heard of it several times and dismissed it several times as a silly project that was going to get hacked and everybody was going to lose their money and it would end in tears. And so it was probably the third or fourth time that it came back up. I was like, okay, maybe I should look into this thing because it's not dying. Read the white paper, started going down the rabbit hole, and ended up going full time in early 2015, working for a security company where I was basically building infrastructure that was being used to help large institutional wallets, specifically exchanges, payment providers, other type of major players that were facilitating a lot of transactions and holding a lot of money so that they would hopefully not get hacked as often as we had seen prior to that. And spent about 3 years working at that company. And then I made a small pivot to, instead of focus on enterprise private key management, to focus on individuals. I felt like there was still a big gap in the market there for people who, if they had been in the space for a number of years, were probably sitting on a large quantity of value in this digital bearer asset. And a lot of people, I think, were just kind of scared to even touch it. Because it can be very fragile. It can be very easy to have a catastrophic mistake happen. And so that's what I've been doing for the past 3 years, trying to take a lot of the best practices that we've learned over the past decade from a lot of hard lessons and a lot of horror stories and build those best practices into the latest hardware and software so that we can make a better user experience for people, because I believe that being your own bank was one of the original promises of Bitcoin, and we still have yet to really get there for a mainstream audience.
So effectively what you're trying to do is give individuals the tools they need to stop relying on these sort of intermediary exchanges, which I assume is how almost everyone does their crypto banking right now, which of course, as you just said, is sort of opposite of the entire point that it was originally sold on, because you're right back to the credit card processor or the whatever model of doing business.
Exactly. I mean, there are some benefits that you can get from still using third-party services if they're all still using this Bitcoin protocol, but there's a level of systemic risk where, if you're just recreating the old system but on top of a new protocol. I want to avoid it, and it's one of those uphill battles. It's like any type of security, any type of privacy, where the defaults tend to be towards highly convenient, but also highly brittle and insecure and not private. And so we as technologists need to continue improving the user experience to fight that uphill battle.
So I guess that dovetails nicely into, I guess, some of the first things I wanted to ask about. So just to get like a common framework here, I was wondering if you could perhaps give, in your opinion, what do you think, and you can also say none if you want, but what do you think are the important technological aspects of cryptocurrency that make it something worth doing or worth talking about, as separate from, for example, the social aspects of cryptocurrency? Because one thing that I should get out, early, because I've never really talked about cryptocurrency before. Obviously, I don't think anything anyone's ever said about cryptocurrency is false in terms of what you might be able to achieve with a social movement. In other words, we know that with social movements, we could achieve almost any random idea we wanted if somehow you were able to get enough people to buy into it, because at the end of the day, what happens with a currency is just what we all kind of agree happens with a currency. So separate from what might happen socially with something if you had enough momentum, I'm curious, what do you think are, if you think there are any, what do you think are the important technological aspects of cryptocurrency? And what do you think those important technological aspects give us that we wouldn't have if we didn't start adopting them?
Well, the term that you hear a lot in the space is self-sovereignty. Really, what it means is that you can voluntarily opt into a new set of rules, not only opt into it, but actually enforce those rules by running the software yourself. And this overlaps a lot with what you were talking about, social movements, because it's a new way of codifying social movements. Instead of them being more abstract and having rules that fluctuate wildly as memes and other narratives change over time, many of the rules that we're talking about, they still get shaped by those narratives. It still evolves over time, but at the lowest level, there is an actual codified set of rules that you can read, you can write, you can run. And so that's interesting to me because I think it's a new path of evolution for these type of networks and social movements and what have you. It's confusing to a lot of people because I think it's a blend of so many different things that at the end of the day, it's much like the fact that just the world in general continues to get weirder and weirder at an accelerated pace. And,
Sure.
and this is just another way that technology is accelerating the weirdness evolution and creating essentially whole new worlds, whole new networks, whole new sets of rules that some people may opt into. And the vast majority of the rest of the populace may not know about it, may dismiss it, and can they're free to ignore it if they don't care about it.
So, I guess following up on that, can you go a little bit more into detail about why you think, or I mean, maybe it's time to get concrete here. So, can you
Mm-hmm.
give an example of an existing cryptocurrency that you think exhibits this property, meaning it has technology, or I mean, technology is a broad term, but it has baked into its operation algorithms which provide the self sovereignty you're talking about, just so we can start talking about specifically whether it does that or doesn't do that.
Yeah, well, Bitcoin is the one that I've been focused on. I have built on top of and played around with a number of the other protocols that are out there, and really the whole space has become so large that it's not even possible for anyone to keep up with all of the different protocols and networks and things that are happening at this point. But I do believe that Bitcoin manages to maintain a lot of the properties that are more important to what we would call self sovereignty. And there are very many different aspects to that. I would say different levels of sovereignty of what you're enforcing or what you're at least keeping out of the hands of manipulation of third parties. It's There's of course the actual control of these assets via the private keys, but then there's a much higher level issue of like what is the actual rules of the network, or how is it governed, how does it evolve over time. And that's where things can get really complicated and sometimes nasty on social media, if we're talking about quote unquote governance or lack thereof. It is, I think, best described in many cases as crypto anarchy. And
Okay.
so, like we said, anarchy has a very bad rap, and that's because governments hate anarchy. It's the natural predator, or the natural antithesis of government. Government is anarchy, but anarchy does not mean chaos. It means rules. The real difference that we're talking about is who enforces the rules. Is it some centralized body, or is it some new sort of amorphous collective that's a lot harder to quantify?
So I wonder, to parse out that sentence before, or sentence, I shouldn't say, to parse out that explanation before I go into detail on either side of it, it sounds like you're sort of saying, well, okay, so there are technological things going on, but are you sort of saying before we even get to the technology that that's not really actually what's happening? Meaning, it's not so much about technology anyway. It's just about the amorphous collective model, and really the technology. I mean, what emphasis, I guess, are you placing on the technology? Is the technology just there because we kind of need something to agree on, or do you think the technology actually does anything? Does that make sense?
Yes. So I have an entire hour-long presentation, I think, that really touches on this topic.
We can
But
link to that in the description as well.
yeah,
Yeah. Okay.
the short version, or at least what I entitled that presentation, I called it "Inverting Bureaucracy with Blockchains."
Okay.
And the short version of describing it is what this technology, I believe, has done at a fundamental level. It has changed the nature of how humans can organize.
Okay.
And if you look at the way that humans have organized throughout history, it's very obvious how society has evolved, and it's been through a hierarchical top-down command and control type of pattern. And the reason why that makes sense is because it allows for specialization in different things. When you specialize in one specific thing, you can be a lot more productive and efficient at it. And then when you build command and control hierarchies, then you have people who specialize at managing other people who are specializing in other things. And it compounds. And that allows us to build the level of civilization that we've gotten to today. Now, the downside to that is that it becomes a lot more brittle. You have more points of failure in this hierarchy. Even if it's not points of failure, you have points of power where it becomes so consolidated that now you have to worry about the fact that power corrupts, and humans in general are very bad at not abusing power when it's given to them. And so what this technology has done, the blockchain data structure, plus the peer-to-peer distributed networks, plus forms of consensus around proof of work, proof of stake, whatever you want to plug into that, it allows you to invert that, where instead of having one centralized entity that is deciding things, it's actually a bottom-up type of mechanism, where instead you have organic consensus that forms by all of the individual actors deciding what rules they want to run, and basically running that code, running the protocols that are compatible with each other, and therefore creating these mesh networks that self-organize and eventually evolve over time.
So I think that's a great framework to continue the discussion, because I think if that's the way you think about it, I think all of my questions that I would have will slot very nicely into that framework. So I don't think we even have to discuss that any further. So let's just take that as a given, because again, I really don't want to talk about the social parts of things, because I fundamentally agree just across the board that anything may be achievable in human history socially. We just don't know. So anything could be possible. Exactly what you're saying could easily be possible. So what I'd like to focus on in that description is the, again, technology part. So I guess almost all of my interest in these interviews in particular could be summarized as saying, why do we need blockchain at all for the thing that you're describing? So what it sounded like you described to me is basically a form of, for lack of a better term, algorithm democracy. In other words, I have all of the people who are citizens of this new entity that's being formed, who are participants in it, are effectively voting in some way as to what algorithm they wish to live under, in a sense. You could think of, for example, the idea of, in any of these systems, which IP address list you choose to broadcast to is effectively your vote in who is part of your collective, right? In other words, at some level, all of these systems require you to start by saying, who are you participating with? Is that a fair assessment? Because I mean, that's just the nature of a network.
Yeah, I mean, it's an opt-in type of thing.
Yeah.
It's really tricky though when people start using words like democracy and voting, because those tend not to be like one-to-one mappable to these systems. And the reason for that is that we don't have a real standard for digital identity. And as long as you don't really have that, then you have to worry about Sybil attacks and people, using computational
Yeah, okay.
resources to pretend to be other people.
I suppose I shouldn't say democracy then. Perhaps I should simply say, for anything that you wish to connect to this network, you are effectively casting a vote with that thing. And yes, like it's not individual people who are the citizens in this sense, because, like you said, there's no way to guarantee that one particular person is exactly corresponding to one particular node in the network. But otherwise, would you agree with that assessment that basically, like, at some level, we are choosing to participate by that initial selection of who do we broadcast to, basically?
Yeah, so in the sense that you can self-organize and write protocols that are, it's essentially a new type of language for you to communicate with other people. That in and of itself does not require a blockchain, and there are plenty of examples of that. Well, I mean, any internet protocol, email servers, BitTorrent, these things do not require blockchains. I would say the blockchain is really more about the history. This is the authoritative record of what has happened in the system, and so if you're doing some sort of economic exchange, then it's important to have the history of who owned what.
Okay, so assuming that we're on the same page there, roughly, that's the part I'd like to talk about. So, if you could, can you give me how you think about which pieces of this are necessary for achieving the social goals that you stated? If we think about blockchain, let's talk about it as being broken up into three rough parts. The first part is one that any technology would in theory provide, and that is that there is simply a block of data that we all pass around. Now, at the barest level, that would not give you anything in particular other than the fact that anyone you communicate with would send back some data, and you would send them some data, right? Part two would be the literal part, the literal description of a blockchain, meaning that data is sequentially signed in some way, meaning that the blocks are not effectively random access, where they are all equivalent, but each incremental block at some level, each, some stride, is then encrypted or signed in some way that lets you know that it came after some other block, which I guess
it's a linked list.
Yes, which I guess is how I would define. Well, it's an append-only ledger. A linked list
Correct.
can insert things. This cannot.
Sure.
At least if we're talking about blockchain, you could talk about linked lists too if you think they're better or different or something, right? Or if they were an improvement over blockchain. And then finally, there's proof blockchain. I don't know a term for this, but to encompass all the possible proof of X things, where it's expected that nodes have also adopted an algorithm whereby they all agree that there is some kind of work that has to be done by somebody, or some kind of bearer. Like, I don't know how you want to define proof of stake, but basically some kind of a token that we all agree comes from somewhere or some computation that says who it is, to distinguish that from, say, proof of work or something. Can you talk about like those three levels and why you think going all the way to the third one is necessary to accomplish what you were talking about? Since Bitcoin goes all the way to the third one, at least. If you count Lightning Network, there's a whole bunch of other stuff, but...
Yeah, so blockchain as a data structure in and of itself is not that particularly interesting. It really predated Bitcoin, though it may not have been called blockchain. There were definitely some papers, I think, in the 90s that talked about these hashed linked lists, or whatever you want to call them. The creation and passing around of data is not an interesting problem. I mean, the internet has solved that with many different protocols. The interesting novel thing is If we want to talk from a computer science standpoint, everybody talks
Mm.
about, well, Bitcoin was interesting because it solved the Byzantine generals problem, which is how do you coordinate amongst a group of random actors who, in this example, want to plan and coordinate an attack against a given target? And how do you do that even if there are malicious messengers that are going between these generals and trying to screw up their coordination? And that's where the blockchain plus the proof of work comes in, because what all of these proof algorithms are doing is all they're really doing is they're adding a known quantifiable cost to creating these new blocks of data, which means that you can't just have a random actor spool up a script and generate a bunch of data that is otherwise valid and could otherwise rewrite the history of the blockchain and pass it around to people and get that propagated. So, it's really an anti-spam mechanism. And that is what allows us to have like better denial of service resistance and anti-Sybil resistance in these systems, so that we can say, okay, we know that there are a theoretically nearly infinite number of possibilities of different permutations of how this blockchain could exist and how the data in it could be structured. But this is the one that we all consider the true authoritative history, because there is no authority that we can ask. We have to have some sort of algorithm that is deterministic that we can all settle upon.
So would you say in general that the do you then have an opinion further on that, or not really? Is it just that, look, anything that we could use that would be able to specifically pick which broadcast piece of data we will append is fine? Meaning, proof of work is just a solution to a consensus problem, and we don't need it for any other reason? Or do you think there is a reason to prefer, say, proof of work over proof of stake, over just a magic oracle that floats around somehow and just we all know the number, who's the node who comes next?
Oh yeah, for sure. And countless hours have been spent arguing the pros and cons of different proof
Mm-hmm.
mechanisms.
Yes.
And I would say in a lot of cases, people's problems with some of these other, especially proof of stake, is more from an economic perspective.
Okay.
Is you could easily argue that it creates more of a the rich get richer type of setup, because basically with proof of stake, the people who have the most money and value in the system are the ones who are getting rewarded for quote unquote securing it by signing these blocks.
Yes.
Now, the reason that I think you find people will say proof of work is better is because it takes an external resource from the network. Proof of stake uses internal resources, the tokens that are already in the network, to secure itself.
Yes.
I kind of see it as a snake eating its own tail, but that's my biased opinion.
That's a bit of a feedback loop, no matter what you
Yeah,
think, because it's like it is, by definition, looking backwards to see what has already happened in the network to decide what will happen in the network.
correct. From a technical perspective, proof of stake is not a new thing. It's existed since probably 2013, but many of the early iterations and networks that use proof of stake found that it was susceptible to things like long range attacks, where this specifically means if at any point in time in the network some attacker gains a sufficient threshold of ownership of tokens, they can essentially rewrite the whole blockchain, because they essentially own enough tokens for everyone to agree that they can do that. Whereas with proof of work, this is taking an external mechanism. It's taking electricity, energy, mining hardware, and at any point in time, the free market is at work, where more people can come in and start competing against the existing, entrenched miners. And this is what we've seen happen over the past decade: is that miners tend not to stick around for many, many years, because it is a fierce competition, really, to the bottom of you mining to the point of barely being profitable, or sometimes in some cases miners actually will mine unprofitably for short periods of time because they're kind of speculating on stuff. But the point being, like, the hardware keeps getting better. Miners are incentivized to keep finding cheaper and cheaper energy, which actually tends to be renewable energy. And that's a whole
Okay,
other
yeah,
ESG
yeah.
debate. But
That I don't care about at all. I mean, not that I
yeah,
don't care about it philosophically. Obviously, energy consumption is an issue, but what I mean to say is that's someone else's argument and is largely based more on factual research than technology at some level. Like, the technology is what it is either way. So yeah, put that aside. Let's just assume that the electricity comes from things that don't harm the planet for now, because that would be the best case, right?
yeah. So from that perspective, also the miners. I mean, there's a lot of misconceptions around what miners actually do, but miners do not have the ability to arbitrarily change the rules of the protocol. Miners are getting paid to follow the rules of the protocol, and if they try to break it, then they're essentially creating an invalid block that all of the nodes will reject, and thus they will not get paid. So there is another perspective that miners are essentially glorified time stampers.
Yeah, well, that's actually what they were sort of called a little bit in the original paper, right? It was
Yeah.
talked about first as like, let's talk about a timestamp mechanism, right? And then it proceeds to follow on. Okay, so focusing on that part, and in fact, exactly what you just said is where I'd want to go with this next. I'd like to talk about Lightning Network at some point, because I think there's a very big difference to me between Bitcoin without Lightning Network and Bitcoin with Lightning Network for a number of reasons. But setting that aside for 1 second, even with the original Bitcoin. So can you elaborate on, again, trying to focus in on whether blockchain actually does anything useful for us as far as achieving the sorts of goals that you stated at the beginning? If we already know that in general we are a network and we are sending data to each other, and as you just said, people inspect the data already because they need to be able to reject blocks that are clearly invalid, because, like you said, it really can't be allowed to just have people putting whatever on there, because other nodes wouldn't even know what to do with the thing that's on it, right? We have to have a level of consensus above the proof of work stage anyway, because after we agree on who did the work, we also have to agree that the thing is something we can actually understand. Why did we need the proof of work part? If in general we are already expecting people to take a look at an incoming block and validate that it actually makes some sense, why couldn't that be the entire protocol? Why do we need the proof of work part? You could think of something like, for example, a Git repository. In general, it's just expected that any valid thing that comes through that nobody has contested will simply be merged into the final product, and it would be relatively straightforward to see how you would do that with Bitcoin. There are some issues you would have to work out, but I'm assuming you have an opinion on why that is not what you would do.
Yeah, I mean, the first two things that come to mind are denial of service resistance and also just convergence. So denial of service resistance, if you look at the way that these nodes are written, they are written from a very adversarial perspective. Before the code actually does many calculations, especially anything that's using like disk resources, it tries to throw away and reject as many messages as possible. So for an example here, if we're talking about like the way that a block gets validated when it comes into a node, instead of requesting all of the block data and starting to parse it and look at the transactions, the first thing that the node actually does is it only requests the 80-byte block header. And by doing that, it can actually inspect that proof of work. And if the proof of work is not sufficient for the current required difficulty target, then you can immediately close the connection on that other node, throw it away, say, you're trying to feed me bad data, and you're not going to be able to waste my computational resources by feeding me data that I already know is invalid. And the result that you get from all of the nodes on the network being able to do that means that they're not going to be accepting arbitrarily valid data that may conflict with other arbitrarily valid data. Like I said, there's a theoretically infinite number of permutations of valid blockchain, but instead you know that you're only going to be getting and processing data that has had enough work applied to it that it's not just some random spammer who's trying to fool you.
I think you said two things come to mind, so I'd like to do the second one as well. But so just to make sure I understand you, because this seems like a totally reasonable thing. In a sense, proof of work in that example is literally just your rate limiter. It's a thing that tries to rate limit how many block updates any particular node could possibly issue in this network over a certain period of time, because since we know that unless they get incredibly probabilistically infinitesimally unlikely scenario, or lucky I should say, they really can't send out very many blocks in any period of time because they would need just too many computing resources. Is that a correct statement of basically what you said?
That's correct, and there are so many other implications as a result of it.
Right.
For example, the actual timestamps themselves. Like, there are many timestamp related aspects of the Bitcoin protocol. Also, economic aspects, of course, with the inflation rate and so on and so forth.
Yeah. Okay, and so did you have a second one? I thought you said two, and I just want to, before I talk about that one, could we talk about the
Oh yeah, well, it was convergence. Basically,
okay, yeah.
being that it's much more likely that all of the nodes are going to be on the same page. Now, this is also somewhat probabilistic. It is still possible, and from time to time, it happens that two miners find a block within a few seconds, and we
Right.
end up with blockchain tips that are not the same. And then usually within the next block, that gets resolved. And that's why when we talk about requiring block confirmations for transactions, that's why you usually want to wait for a few, because there can be issues where not all of the nodes on the network are on the same page.
So would you say that's, I mean, is that basically it? Meaning I guess, can we even elevate that one further? Could we say that in general, blockchain with a proof of something, where that something is presumably not capable of being done too often, the primary goal is just slowing it down, in a sense. Meaning, it doesn't really provide anything else. It just is there to make sure that the network runs slowly enough that we don't run into the kinds of problems that we would expect to run into if people could simply flood the network, and mostly adversarial. Though for convergence, like you said, even with only good actors, it's theoretically the case that you could have convergence problems with a congested enough system. Although, in theory, if everyone's a good actor, no one's double spending, no one's doing it. So who cares, I guess, how you converge? But, even with mostly good actors, let's say, convergence becomes an issue there.
Yeah, like I said, there are many implications as a result of it, but proof of work, for example, was actually based upon the Hashcash algorithm, which was developed in the 90s, and Hashcash was developed as an anti-spam email mechanism.
Yes.
I've actually implemented Hashcash in other projects as anti-spam mechanisms. I use it on my own website on my contact form. So, requiring some sort of computational resources to be expended is a great way to stop spammers, because they're looking just to be able to send out as much data as quickly as possible.
Okay, so I don't want to keep you for too long. So at any time, feel free to tell me that you're out of time. Let me open up into a small window of that, because that actually gets at something that I think is a very interesting question that I'd like to explore further. So it seems to me that aspect, the rate limiting, which I agree, for distributed consensus protocols, I haven't spent that long thinking about them, so I guess I'm not prepared to say I 100% agree, but let's just say that my intuition would tend to agree with you, which is that if we are going to make a distributed consensus protocol, having it go slower rather than faster is going to make it more likely to be stable, not less likely, so to say the least.
Mm-hmm.
Can you talk about the tension, though, that comes with the fact that we also are trying to make this thing scale up to a large number of transactions? Because these two things are sort of opposed to each other in terms of what you are asking the technology to do. And so, can you kind of elaborate on, is that slowdown really something that ever can sort of persist throughout the entire system anyway?
Yes, and this is definitely the crux of one of the greatest periods of contention in the network history,
Yes.
and it's somewhat a technological issue, but I would say it's also an economic and philosophical issue, and that is what has
Okay.
resulted in there being splits, forks in the protocol, and thus forks in the actual blockchains and networks themselves. And so, like I said, there are many implications to slowing this down. One of them is the ability for the average person to be able to sync the entire history of the blockchain, starting from scratch. One of, I think, the
Right.
values that is held dear on the Bitcoin network is that not only today, but preferably 10 years, 20 years, 100 years from now, we would like it to be accessible for people to be able to audit, and validate the entire history of the network themselves
Right.
on a fairly affordable level of machine, whatever that machine may be at the time. And so, in order to be able to do that, you have to understand that this is an append-only blockchain, and whatever you put in it, for the rest of time, as long as people are using that protocol, someone is going to have to download it and verify it if they want to get to the current tip of the blockchain in what we would call like a self-sovereign state, where they're not just like using a checkpoint from some other source that they got. So that has
And
been, I
just
think,
to
one.
clarify that for some folks who may not be familiar with it, and also just to make sure that I understand, because since I don't work with these things, it's always good to check my assumptions. That process is required specifically because, I guess I should say, that process involves more than simply, for example, checking the headers to see that they're assigned. Because
Right.
if I understand correctly, the way that they originally designed Bitcoin, and to my knowledge, I guess the way it still works today, is that it is based on a transaction model, which means that in order to verify the final block, whatever the latest block is, you kind of need to know the state of all Bitcoins, what their transaction status was going into that block, which means that you sort of have an inductive proof of just, you have to start at the beginning and track every Bitcoin's transactions to see that they were all signed correctly in each signed block after you check the signature of the block, rolling forwards, because some Bitcoin that the last time it was traded was 10,000 blocks ago, you need to know that state going into the current block. Is that a correct statement?
In order to be sure that it hasn't been double
Double
spent,
spent.
yes. And so, we talk about the blockchain a lot, and then other people will say, well, it's a distributed accounting ledger. Really, when we're talking about the quote unquote ledger of what the current state of Bitcoins are, then what we're talking about is called the UTXO set, which is the unspent transaction output set. And like you said, the only way to know what transaction outputs have not been spent is to iterate through every transaction that has ever
Yes.
happened and build that mapping up. Now, what we're talking about here is what I consider to be the most robust security model that the Bitcoin system has to offer. There are
Okay.
many other security models that you can operate in. One of them is called simplified payment verification, where all you do is look at the headers, and then when you want to know about specific transactions, you can query nodes and get specific proofs that are much more efficient and can prove to you that a transaction happened in a given block without you having to download the whole block. There's a lot of trade-offs to that, and then of course a lot of other people are just using centralized providers who are just keeping their own
Oh,
internal
yes.
database, and they're not validating anything at
Anything.
all and just completely trusting that. So most of the time what we end up talking about is this ultimate level of self-sovereignty and self-validation. Some people call it trustless. Basically, you're not trusting that anyone else on the network is being honest with you. And the only way that you can do that is by going out on the network and asking for all this data and checking that every bit of data over the entire history that you receive is following the rules to which you agree.
So I guess I kind of want to go two ways with this here, so it's a little bit difficult. But let's just finish up this one. So again, can you finish talking about, because I kind of interrupted you there just to clarify that one point. Can you finish talking about that tension between needing to process a lot of transactions and wanting to have what you're talking about? So as you said, there's an issue with large transaction volume right away, separate from the fact that the Bitcoin protocol can't really do it at its base level because of its proof of work requirement and how hard it is, at least for today's computers. But uh, you know, you were saying that there's a space issue there too, which is totally true. If anyone in particular wants to be able to really validate the entire blockchain from start to finish, then presumably they would want to be able to download the whole thing, which, if you have a rate limit on it, is much more plausible. But keep going from there, because I don't think you were done yet.
Oh, not by any means. So yeah, the problem with this, if you start raising that limit even only linearly, then over time you can end up with a geometric, if not exponential, increase in the total amount of data that needs to be downloaded and verified. And this is something that I'm very fascinated in, other than just the fact that I participated in a lot of those scaling debates. One of the projects that I do on an annual basis is I actually run nodes for many of the popular networks that are out there on the same machine that I've been using for four or 5 years now as my benchmark machine. And I see, how long does it actually take to fully validate the state of this system from Genesis without using any tricks like checkpoints, which most of them are doing these days.
I see.
And for most of the really popular networks, you can look at my posts year after year. It's becoming it's taking longer and longer, and not just like linearly longer, but like most of the Ethereum nodes out there, for example, are taking my computer over a month to completely sync. And that's on a really fast solid state machine.
Okay.
Most of it's usually disk IO is what is the throughput bottleneck on most of these things. And I'm doing this on a fairly top of the line M2 NVMe drive, which has several gigabits per second of disk I/O. But it's an interesting thing to ask, I think, as a question, because you then have to ask yourself, well, now what in many cases they're doing is they're optimizing for cheaper transaction fees, because if there's less congestion, then there's less economic contention to get your transaction into a block. But the natural trade-off and conflict that you have here is you can either have really cheap block space and a lot of block space, and have it cheap to transact, but as a result, on popular networks, it will be very expensive to verify everything. Or the flip side, which is what Bitcoin tends to optimize for, which is we're actually going to let the economic side float, and you may have really expensive transaction fees, but on the other hand, that the cost of doing full verification of the entire system is going to remain sane. And so this is the major economic and philosophical conflict that really I think any public permissionless network is going to have to deal with.
And so getting back, first of all, that makes perfect sense. I hadn't really thought much previously because it's perhaps the kind of thing that an implementer thinks about quite early, but that if you haven't actually gotten in there to do something with, you wouldn't necessarily consider, which is just if something's in theory auditable, that's one thing. But if it's not actually in practice auditable, then that means that it's no longer auditable, right? And so, makes perfect sense. To push that a little bit further, though, separate from even just within Bitcoin, we still have to process the transactions. So if you want to scale this up to something that's more than the 1 megabyte every 7 seconds or whatever, I don't know what the current estimate is for how much throughput a Bitcoin network does these days. It's probably higher than that. But if you want to push your transaction rate up above that, which it seems like you have to do if you want to actually use this to create any kind of an economic system of any appreciable size, what's the answer? Because if we're saying that all of these things, we went through like why we need each of these pieces of technology, uh, for the block for why do we need the signing? Why do we need proof of something? Or rather, why do we need a rate limiter? Because it kind of sounded like we don't really care about proof of something so much as we just need a rate limiter, and that's just the way we have to do it right now. Um, how do we move past that? Because if those things are necessary and they fundamentally limit the number of transactions, does that mean it's dead in the water? How do we get past that? Because it sounds kind of like you can't, right? So could you talk a little bit about that?
Yeah. So I think the first few months of Bitcoin's existence, people were theorizing. I mean, it was already obvious that you could only do a handful of transactions per second on the network, given the block limit, which was also another denial of service, anti-spam mechanism. Actually, the very first version of Bitcoin didn't even have one. I think it was added maybe after 6 months or so, when someone realized that a gigabyte block coming through would be very bad.
The original implementation of the protocol was just like, the block's as big as you want it to be.
Yeah, I mean, I think there was an implicit limit of maybe 32 megabytes because of like 32-bit system or something like that. But there was no codified limit at the time.
Okay.
So yeah, what do you do? Well, at the time, way back then, some people theorized, well, Bitcoin is just going to become like gold and it's going to be stored in centralized vaults and people are just going to be passing around IOUs like they do with like paper gold certificates and so on. And, that's not the optimal outcome because then, it's probably a small number of custodians who end up controlling most of the value. And you could argue you're essentially recreating the existing system in a sense.
Yes.
Also, you run into potential governance issues if the vast majority of the network is controlled by a small number of actors. So what happened? Actually, Satoshi Nakamoto came up with a concept called payment channels, and not much was done with them for a number of years. There was some very early payment channel work done around 2013, 2014 in the Bitcoin J project. And a few like crowdfunding mechanisms and other stuff happened, but these payment channels were very limited in what they can do. And what a payment channel is essentially instead of creating a Bitcoin transaction and broadcasting it out on the network, and then it gets mined, it goes into a block, and so on and so forth, you can put your funds into a multi-signature contract on chain. And then after that point, you and your counterparty who both put funds into this contract can start passing Bitcoin transactions that spend those funds privately between each other without having to broadcast them to the whole network. And then if you get to the point where you decide you no longer want to economically interact with each other, you can broadcast the final state of that those series of transactions that you've been privately broadcasting back and forth. It goes out onto the network, it goes into a block, and that you would consider your settlement of funds. This, you can see why this has creates a lot more efficiency if you have another actor that you are trading with on a regular basis. But it's not that great. It only helps it if you and one counterparty are constantly doing some sort of activity. So for example, there was a video streaming service that allowed you to do this for micropayments, and then once you were done streaming the video and paying for it, a few kilobytes at a time, you could close your transaction.
Gotcha. And just to be clear, I assume this was implemented similarly to Lightning Network, where when you post back to the root blockchain, to the actual Bitcoin blockchain, whatever you want to call that blockchain, there's a time lock of some kind so that that you're not broadcasting old information or something like this. So is it still a contended? It's an adversarial broadcast system, just like Lightning Network, or was it different?
Yeah. I'm oversimplifying it. So what you're doing, you're actually creating some game theory, and there's some other logical branches to these transactions where if someone tries to screw you over by posting a previous state, you can steal all of their money.
Okay. So it's like a penalty-based adversarial thing, much like Lightning Network is, I assume, or rough, with some differences, I would assume, because Lightning Network must be different, or they wouldn't have called it Lightning Network, I guess.
Yeah. So this system was far simpler.
Okay.
Lightning Network is far more complicated, but also far more useful and far more robust. So like those old forms of payment channels have not been in use for at least 6 years, I think, at this point.
Okay.
Lightning Network kind of supercharges the idea of payment channels by creating a network of payment channels
Mhm.
so that you no longer have to be directly connected to your counterparty that you want to send or receive funds with. Rather, it uses a sort of onion routing mechanism to be able to securely and privately have those payments forwarded through an arbitrary number of other hops along the network and eventually reach the final destination. And so this allows you to have that same level of efficiency, but with far greater reach. Now, there's a lot of other trade offs involved, and Lightning by no means will ever have the same security model as on chain Bitcoin
Right.
for a variety of reasons. The additional complexity, the fact that your keys are probably going to be hot rather than cold, though it is possible to do some cold payment channels, but they end up being a lot more limited because you can't actively route funds through them. But Lightning Network was originally, I think the white paper was in late 2015 or early 2016. Early testnet versions of it went online, I
Could I
think.
just clarify one thing, by the way, because I just realized I was assuming something with what you said.
Mm-hmm,
Hot versus cold keys. Could you
mm-hmm.
just I'm assuming you mean whether or not they're easily accessible or not, but elaborate.
Well, yeah. So we tend to say a hot key is a private key that is on some sort of internet connected
Right.
device,
Yes.
and this is risky because
It can be stolen.
hackers can get in, malware can get in, so on and so forth.
Gotcha.
So yeah,
Just wanted to make sure I wasn't misinterpreting what you said because I was like, well, I don't think I've ever heard that term before, but all right. Because yeah, if one of the things, also I should say before we continue, it just occurred to me. Thank you for not using too much terminology. This has been very like acronym free, which I think will be great for everybody, including myself, obviously, who doesn't spend a lot of time in this world. You know, people can easily just use things. You're like, wait, okay, go back. What is that term? Okay, sorry. So
absolutely.
so continue. So you said that it doesn't have the same security, the hot versus cold keys, and then sorry, continue.
Yeah, because really this is optimizing for a different use case. This is optimizing for fast, convenient payments. Probably small payments. If you're going to buy a house or a car, you probably aren't going to be using Lightning Network. This is really meant to be more of a mainstream consumer retail type of network. So. Putting tens or hundreds of thousands of dollars into it is certainly not recommended.
So if we assume then that that is what most transactions have to go through, and only very large, I guess, infrequent transactions would go through the main channel, uh, haven't we sort of kicked the can down the road a little bit? Like, why, if we're willing to accept all of the lesser, sort of like obviously it's going to have all of the problems that you were worried about if you get rid of the rate limiting that we talked about before, or if you don't have the things that were supposedly necessary at the root blockchain on the one that people are actually doing most of their transactions on. What was the point of the root blockchain part?
So the main chain, as we call it,
Yeah.
is the settlement layer. You can think of it as, from an economic standpoint, this is not a new thing. There are already high frequency, fast payment networks, whether it's credit cards, PayPal, what have you, and those things don't settle instantly. In some cases, their settlement assurance is on the order of weeks or months.
Yeah.
And the settlement is when you have finality that your money isn't going to get taken away from you. So if you think of it from a validation standpoint, why should my grandchild have to validate that somebody bought a cup of coffee 50 years ago? Like, what does that matter to them? All that you really care about is in a system like this is you just want to have an assurance of who owns what now. You don't necessarily care about all the nitty gritty details of every economic transaction that ever happened.
Gotcha. Okay, so I think most of that uh, architecture stuff is pretty well sussed out based on what we've talked about so far. So now I'd just like to go back to the original question, which is assuming that technology stack. I mean, I guess I should ask you first. So is that technology stack, meaning we have a root blockchain with a rate limiter on it, so and a consensus protocol. In this case, they're sort of one and the same, but we satisfy those two things. We have a limited rate of clearing transactions, and we have some arbitrary system, doesn't matter what it is, for deciding how we pick which broadcasts we actually retire on any particular node, so that they can reach consensus or convergence. We have that as our root system. We then have a sort of wilder, faster system as a second layer down, which will just use the original system to, I guess, one way we might say is conflict detection. So if somebody starts to try and do anything particularly weird, when we go to clear it, we will know that there was something bad in the system. How does this technology achieve going forward the goals that you set out at the beginning? So the self-sovereignty, to the extent, however you wanted to define it, why does this accomplish that goal?
Well, as the complexity of the system continues to increase, people will have more and more options of how they're interacting with it. So the premise of at least Bitcoin main chain plus this new second layer technology, Lightning Network, it's still being built with all of the same value propositions imbued into it. So if you want to, you can run your own Bitcoin main chain node, and on top of it, you can slap one of these Lightning Network nodes, and they're talking to each other. They're interacting. The Lightning node is actually using the Bitcoin node to determine and get the settlement assurances. And from that perspective, you still maintain that self-sovereignty. Not everybody's going to do that. You can use third-party services. You can use lightweight clients that make other trade-offs around the security and the convenience of what you're doing. But I think the important thing is that you have the optionality, and it's still feasible for someone who puts in a little bit of time to do it, to do so. It's not necessarily going to be a push button type of just jump right in, though there are people who work on products like that. I mean, my company actually had a
such as yourself, it sounds like,
node. Yeah, so I've dealt a lot with trying to thread the needle of those usability challenges and being self-sovereign and helping other people be self-sovereign rather than just taking everything and saying, look, I'm going to do it and you're going to trust me. It's it can be very very compelling to want to do that because it makes it easier for everyone, but it creates a more fragile system. And I guess for people who may think that this system of increasing complexity is daunting or may not make sense, I actually liken it to the internet itself, the OSI model. If you look at the way the Bitcoin blockchain works, it is a global flood fill broadcast mechanism. Has some similarities to the lowest layer of the internet. You put some data out there and it goes out to everything on the network. And if you think about trying to scale up Ethernet, you and I would not be able to be having this conversation the way that we're doing right now, streaming audio and video, if we only had Ethernet, because the other billion people on the internet would also have to be processing this data at the same time.
Yes.
So that's why we need routing layers.
Yes.
That's why we need to create more efficiency. It is a bit more fragile. It is a bit more complex, but it gives us orders of magnitude more efficiency from a resource usage standpoint.
So not to keep you too much longer, I'll try to now wrap up with the crux of the whole thing, because I feel like I understand everything you just said and what your perspectives are and what you think the technology is and what you think it does. Can you walk me through an example of how this self-sovereignty would actually do something in practice? So I'd like to give you a hypothetical, Maybe you can modify my hypothetical if you think we need some extra things in it, but simplest example, I think you already said buying a cup of coffee. So I am a person in the world, just an average person. I have no special connection to banking or anything. And I want to buy a cup of coffee from some place that is also presumably going to use Bitcoin. So I'm going to use Bitcoin and they're going to use Bitcoin. How would self-sovereignty help me do something with this transaction that I can't already do in the real world? In other words, what is it, and you can pick multiple or just one, what is a scenario where realistically, during a real transaction that a person would actually care about, the self-sovereignty does something? Or is that the wrong way to look at it?
Well, yeah, I mean, I think it's a very privileged Western perspective of looking at it because you and I, we have access to great financial infrastructure. And I'm not the best person to talk about this. There's some great people at the Human Rights Foundation who work with people in countries who do have much better use for censorship-resistant payments. I do not find myself being censored very often. It's probably only a handful of times throughout my life when I found my transactions being censored, but that's a very privileged position that I found myself in.
No,
So,
I don't mean that, actually.
yeah.
I mean assuming no privilege. So tell me, like, give me the unprivileged scenario. And if you'd rather, if cup of coffee is probably, I only use that because you used it. Let's use something
Yeah.
that would be more likely to be deprivileged. Bread. Something to feed my family. Give me the scenario where this helps me.
Possibly, but really, when you're talking about self-sovereignty or censorship resistance, what is generally more interesting is what are the transactions that authorities don't want you to make. So it tends to be things more in legal gray areas, whether that is like sex work, pornography, drugs that may be gray market, black market, highly regulated things. A lot of people end up finding.
Can we just pause 1 second, though? Okay, so I'm not sure I understand that leap then. So in one case we were talking about, you were saying that looking at the other way was a privileged view. Certainly sex work is not a privileged view, meaning we wouldn't normally consider, well, I think it's great to enable as many types of people to do as many types of things as possible. Surely we're not talking about access to sex work being censored as the primary thing that a person living in a third world country without access to financial services is concerned about. So can you clarify that a little bit? Because gray market doesn't sound to me like privilege versus unprivileged. So the two things you just said didn't really line up.
Well, no, these are very many different types of people, and I can't speak to any one specific thing.
Yes.
Now, people in third world countries, it's more likely that they don't have access to banking and payment infrastructure.
Yes.
So they're more likely to be using physical cash for things.
Yes.
They're more likely to be in a country that is more susceptible to high inflation rate. So, they may prefer to opt out of that system because it's also, being oppressive from a purchasing power of their income perspective. That's the thing about this space. This is a neutral tool. People can use it however they like. And if they're able to economically interact with other people without meddling from third parties, I think that level of freedom is generally going to be good for everyone to prosper, except for, of course, the people who are trying to control what we're doing.
Okay, so that's what I'm trying to get to. So can you give me an example of where the self-sovereignty, so it's like a concrete thing of like, here is an example of a transaction that would currently be censored, and here is how this system would accomplish that in a way that another system wouldn't, right? So like given all the technology you said, so proof of work and all these sorts of things, what is an example transaction that is what we're trying to enable with the self-sovereignty?
Well, there's transactions that would be censored for any number of usually political or regulated type of reasons. And then there are other transactions that may just not happen because you don't have the infrastructure. So take the internet, for example. We have this amazing network now that billions of people can connect to, and they can start interacting and communicating with people regardless of geographic boundaries, jurisdictions, what have you. And yet, a lot of our payment infrastructure still has really weird rules and blocks that are based upon jurisdictions and regulations of nation states. So, it should be possible, or why can't a random person in a third world country who only has a cheap Android phone and a kind of crappy mobile connection to be able to get onto this network and start earning money by using their own intelligence and being able to perform actions which may not be worth a lot of money to people in Western society, but may earn them enough pennies or equivalent thereof in a new cryptocurrency that they can now receive and hold and use themselves without having to go through banking infrastructure that it probably won't even be available to them because there's just not enough overhead to make it profitable for banks to do that.
And so drilling down on that, right? What is it about this technology that enables that the current banking system doesn't? So, for example, if we're taking this person in a third world country, I'm not sure I quite get the hypothetical, but you're saying they are doing some kind of work on the internet to make it a little more concrete. They're proofreading or translating something into their native language because they happen to have learned to speak English, and they take an English thing in and translate to their native language, which is providing a service that someone will pay for. Is that kind of what we're talking about here?
Sure. I mean, you could even just say like Mechanical Turk type of work. I don't know.
Yes. So something they're able to perform on their Android phone, they are getting paid in this system. And the what I'm trying to get at is, okay, so tell me an example of why this doesn't work with the current system and why it will work with the new system.
Well, I think one of the most common reasons that it doesn't work is that there are no banking providers that even offer them the ability to create accounts that can receive or send money. And that may be for any number of reasons, whether regulatory or I think it's probably more just profit motivated. If someone's only earning a couple dollars a month, why is a bank going to want to dedicate the resources to setting up all of the infrastructure required to maintain that account? They're not going to be able to extract much value from it.
Okay, so there were two things you said there. One was regulatory. And one was the fact that a bank might just elect not to provide this, right? So, question for the first one, if regulatory was the concern, how will this system help? Because surely if this became common enough that a government wanted to stop it, how does regulatory issues not just stop it?
Right. So when I was thinking more of regulations that create a bunch of paperwork and overhead and compliance, that raises the cost of opening and maintaining accounts in traditional infrastructure. So that I think turns a lot of banks off to servicing lower tier people. Though regulatory from a how is government may crack down on it type of thing. That's an interesting question at which we can look to China to see how that has been going. China has been cracking down on Bitcoin since probably 2014 or so, and there's always going to be the issue of government has a monopoly on physical violence within its jurisdiction. Government will always be able to say, look, if I catch you doing this thing, I put you in a box or I fine you or some sort of other punishment. And, technology won't be able to stop that. But I guess the cypherpunk side of me says that, look, governments have been passing regulations on technology for a long time, and we've seen them fail. I mean, just look at piracy, for example. People do illegal stuff offline and online all of the time, and governments and their law enforcement systems, they don't have nearly as much resources as they would like you to believe. So they can't actually enforce things as well as some people might think.
But that's also true of the current banking sector, so I'm not sure why that's an argument in favor of cryptography. So, for example, if you believe that the government isn't capable of creating regulatory burdens to something, then why do you think the current banking sector has those burdens?
Well, it's a matter of pressure points, right? Is that if you're doing things through large regulated companies, you have sufficiently centralized that system that the regulators and law enforcement, they have a small number of entities that they can go to and put pressure on to say, you need to comply with this. Now, if and this kind of goes back to, I guess, any sort of social movement or whatever. If you have a sufficiently distributed enough system or a sufficiently distributed enough group of people, you can't shut it down. You can't stop it. I mean, you can make threats and you can put some token people in jail and whatnot, but that is, I think, one of the underlying premises of the cypherpunk movement and a lot of the cryptographic technologies that spawned off of it, is that a sufficiently distributed system cannot be shut down. So it's hard to stop software, is really what I'm saying. If it's because it's hard to stop the flow of information now that we have the internet.
Uh, so I guess I'm not quite sure I understand that argument. How many nodes do you imagine there to be, I guess, in the root blockchain of Bitcoin operating in the end game? Meaning, where do you think that number, what is the cardinality of that number, if you will? Like, what order do you think that number is?
I mean, it's been fairly flat for a number of years. So there's currently around 10,000 publicly reachable nodes and somewhere between 50 and 100,000 extrapolated total nodes. They're not all reachable. They may be behind a NAT. And it's hard to say from like a percentage of users, like how many people bother to go to the extreme of running it. But there's also an argument that it's not necessarily about whether people are running those nodes today, but if they have the optionality to do so, and if it's possible for them to afford to be able to do so if something in their situation changes and they feel like they need to take on that additional level of security. So, preferably I would want to see everybody running their own, but I know that it's going to be a small minority of people who bother to do that.
And if I may, sorry if this is going too long. Is this too long?
No, we're good.
Okay. So if I may, I still don't quite understand how that really works. So the reason everybody isn't their own bank today is not really because they wouldn't like to be able to do the things that a bank can do. It's because of the regulation. So why do you think a government couldn't simply prohibit people from running Bitcoin nodes, thereby limiting the number? Because even the number you just said was very low. 10,000, there's probably 10,000 banks.
Any government can pass pretty much any type of law that it wants to, right? It is the supreme rule of its own land. Part of this, from a geopolitical standpoint, it's a global game, and at least so far, while we do see some cooperation between some superpowers and other nation states, it's highly unlikely that they're all going to get on the same page and agree to unilaterally ban all Bitcoin usage or all usage of some technology. I think that at least the smarter politicians know that even if you do ban something like that, you just create a black market. Now, the number of nodes would drop,
ban.
The number of users would drop, but it would still continue to exist.
Not ban, just regulate. Because I think that's also a thing that I've seen before, and I don't necessarily think it's very compelling, which is to say governments, if they see people using something, they don't tend to ban that thing. What they tend to do is regulate it so that they can control it. And I think it's a much harder argument to say that they won't do that or can't do that because, especially as you see already with cryptocurrency, there are large players. And the incentives for those large players to comply with the government, if the regulation isn't particularly burdensome, are quite high.
So I believe that every agency within a government is going to do the most that it can to corral this technology and try to get as much of it under its purview and
Mm-hmm.
say, we should be able to regulate it from aspects X, Y, and Z,
Oh
as
yes,
much as possible.
yes.
And
EPA,
that's
IRS, DOJ,
yeah,
like they all will want something. Yes.
yep. And so it's going to be interesting to see how that plays out. They certainly will regulate any large centralized actors, especially any that are handling other people's money, because that falls under various financial regulations. It's nothing really new there. They're going to be grandfathered into all of the like money transmission and custodial issues. But just from like a technology standpoint, I think at least in the United States, there's a very strong argument that the use of open source technology is basically a freedom of speech issue. That what we're doing is we're interacting with each other voluntarily, we're communicating with each other over the internet, and that is not something that the government can regulate unless they decide to somehow repeal the First Amendment.
Uh, I guess that I don't follow at all. Okay, the First Amendment uh is really not implicated very heavily in banking regulation, though, at least from what we've seen. So I guess I'm not sure why. If that were a useful defense, surely it would have been raised already by a bank at some point.
I don't think really banks would care enough to raise that as a defense. But I'm not the lawyer, but I am repeating something that some of my crypto legal
Okay.
friends on Twitter have definitely said a number of times. So I'm not the constitutional law expert, but I think that from the premise of the fact that this system, it was not created by the government, wasn't created by the Fed or the Treasury or anything like that. I think if we're talking about the banking system, which really does all flow from those original entities, and they get to say, well, you're just further down the hierarchy, so you have to comply with all this stuff. That's probably how they would make a legal standpoint of we get to regulate all of these activities, whereas we're talking about a communication system that was created by an anonymous entity and is run by thousands of people all over the world from a voluntary standpoint.
So that's good. I'll put that on my list for interviews. Maybe afterwards you could recommend a person to talk to, since I love First Amendment law, so I would love to have a conversation about that. Okay, so and then for the regulation point, we'll just keep brief because, like I said, I'll be doing more interviews, so I can also ask other people to elaborate on some of those. The flip side of that, just to finish up, you said is making it worthwhile to do was another reason that people might not have access to these banking services. So how does this help? Meaning, we already see that there's a lot of fees associated with things like using Bitcoin and that sort of stuff. How does this technology help reduce the cost of interacting with the banking system if that is a key aspect of self-sovereignty?
Right. Well, I mean, I don't think it's necessarily going to help with using the traditional banking system. It's more of a question of, can we create a closed loop economy that is more efficient and able to work inside of? Because right now, even if you get into Bitcoin or you're using Lightning or whatever, I think most people, because of how new it is, it's not a closed loop system, and they end up having to use on-ramps and off-ramps. Those on-ramps and off-ramps are probably going to be charging fees. They also tend to be regulated. They tend to be choke points. There's a lot of bad things that tend to happen at on-ramps and off-ramps, like we said, with exchanges getting hacked or exit scamming, so on and so forth. So from that perspective, I think it's still very early days, because I want to see native internet currencies be able to be fully closed loop systems where you're not only buying stuff with them or storing your wealth with them, but you're also earning with them, and being able to complete that full life cycle. It also means that businesses need to be able to pay other businesses
Yes.
with these currencies in order to
Right.
be able to facilitate that.
All right. Well, thank you very much for talking with me today. I think we got through a lot. It actually sounds like we probably don't disagree on very much, actually, based on your answers. I would suspect that probably other cryptography people might disagree with me more, because it sounds like you had a pretty realistic picture of what actually is or isn't possible. That didn't sound particularly fanciful to me. Presumably, it also doesn't sound very fanciful to you, but it does sound also. Tell me if this is an unfair summary. It does sound like at the end of the day, it does lean pretty heavily more towards the social aspect than the technology aspect, since it didn't really sound like you were actually that. It didn't sound like you actually thought there was that much of the technology implicated. In a sense, you were like, if we have the bare minimum for rate limiting and selection, then that's the technology. Like that's the extent to which we really care about this technology. And most of the other things are about, like you said, hoping that government can't intrude too much because it happens to be something that can be multinational. Hoping that people adopt it so that business could pay each other without having to go through on ramps. I mean, is that an unfair characterization or not?
So this is really hitting, I think, on the complexity of the system. It's so multifaceted. The technology is important, but there's also the game theory. There's the economics. There's the regulatory aspects. You can get into, like I said, like the geopolitical implications of what happens with nation states if they start competing more directly against each other with regard to crypto. And we've seen
Right.
legalization of Bitcoin in some countries, and some believe that this is just the beginning of dominoes falling. So
is that good or bad, by the way? Like, do we know if it's
good for
or
who, bad for who?
Yeah.
It's going to be good for some
Okay.
people. It's going to be bad for some people.
Okay.
But this is all this complexity that we just barely scratched the surface of is why I've been so fascinated with it for a decade, and why it continues to fascinate me. And I just try to soak up as much of the information of what's happening as I can. And I certainly have fanciful, optimistic hopes for what we may see the world look like in a few decades if this progression of technology results in social changes, results in economic changes. But that is, getting more like Nostradamus.
And I guess as a final thing, one thing that I kind of think about with crypto, and I'll just end on this, is sometimes it's unfortunate for technology people because you hear a lot of claims about crypto and you're like, well, the technology doesn't really do that thing. You're sort of talking about something that you're just hoping happens because we use this thing or something like that. And we did touch on a little bit of that, but like I said, thank you for being refreshingly clear on a lot of this stuff. You didn't say a lot of things like that. You weren't like, oh, and then, technology is X and then magically we get unicorns that ride through the sky, which, sometimes it sounds like. Tell me your reaction to this as the closing thought. Is there a certain degree to which the over-optimistic or fanciful flying unicorn nature of the discourse around crypto, is that also somewhat of a strength? Which is a weird thing for me to say because it annoys me that it occurs, but since there is so much of a social component to it, is having a fanciful notion of what it will achieve, even if we know full well that that's mostly a lie technologically, is the lie perhaps a necessary motivation to get the social part to occur, which, if it occurred, would actually accomplish the thing, even though the technology itself does not guarantee it that outcome?
Yes, it's a feedback loop of memes and narratives. And
Yes.
I also have a whole article that I wrote about this. You can make the argument that, we're memeing certain things into reality. And that has become literally true in the case of some of these meme crypto tokens and
Yeah,
whatnot.
that's true.
Though, I tend to think that those are going to be more flash in the pan. But regardless of which of these protocols or networks you look at, that is also kind of the dark side of it, is that we have incentivized people to, pump their bags. And so some people who are in it for get rich quick type of thing will make all the promises in the world and they don't care. They just want to get enough other people to come in and invest money in the system, and then they're going to dump it.
Mm.
On the other hand, it creates some interesting incentives for the people who are in it for the long term and
Yes.
who care about building the technology. And I do believe I'm one of those people where, I don't have to keep building this stuff if I didn't want to, but as you've seen, like, I think I'm fairly realistic about where we are right now, and I think I'm going to be working on this for the foreseeable future because there's still so much left to do. This is not, mainstream adoption. While we are at a mainstream level of at least, I think, people being cognizant that the technology exists, very few truly understand what it's capable of doing or why they should care about it.
All right. Well, thank you very much for joining me today. It's been a pleasure talking with you. And for
Thanks for
anyone out
having me.
there who wants to find you or follow you, uh, what's the best place to look you up online?
You can check out my website at lopp.net, lopp.net. And if it's easier to remember, bitcoin.page will take you directly to my resources that has about 1,500 different links to various educational sites about Bitcoin.
Awesome. Well, thanks very much.
Thank you.
Have a good one.